Welcome to Brain Vision.
So for this drawing, we're given a series RC circuit that it has a capacitance C1 of 0.000026 farads and a resonant frequency F0 of 7.3 kilohertz. However, the generator for the circuit has a frequency of 5.6 kilohertz. Now we want to plug in a second capacitance C2 that we're going to add to the circuit such that the resonant frequency changes to being the same as the frequency of the generator. So before we do any of that, we use the resonant frequency F0 to find the value of the inductance of the circuit. Using the standard definition of resonant frequency, we solve for L and we find this. We find about an inductance of 0.0001828 henries. Now, we want to lower the resonant frequency. We want to lower the resonant frequency from 7.3 kilohertz to 5.6 kilohertz. So since we're lowering the resonant frequency, that means we must increase the total capacitance. In order to increase the total capacitance, we need to connect C2 in parallel with C1. This is because capacitors are connected in parallel at their capacitances. So now we can write the expression for the resonant frequency. Instead of writing just C1, we run C1 plus C2 since they're in parallel. Use this expression, and we make this expression equal to the frequency of the generator, which is 5.6 kilohertz or 5,600 hertz. And for this, it's just a matter of solving for C2, which is the unknown added capacitance. And remember, it's connected in parallel to C1. And this is the following expression for C2. And we just calculated L previously in this exercise. We know C1 and we know all the other quantities. So it's just a matter of replacing everything and obtaining a capacitance of 0.000000182 farads. That must be connected in parallel to C1 to make the resonant frequency equal to the generator's frequency.